We have so far in this chapter really been focusing our work with these trigonometric functions on our special angles, like 30, 60, 90s, 45, 45, 90s, looking at our sine, our cosine, our tangent, and their buddies on the unit circle. However, we should realize that not all angles are going to be nice. They're not all going to be in those 30, 60, 90 triangles, 45, 45, 90 triangles. So there are some situations where we maybe want to deal with angles that are not one of those values. However, we may be able to find our value using those special angles. So we are going to be looking at the sum formulas and the distance formulas for sine, cosine, and tangent. All right, so if I look at my sum formulas, if I have the sine of two angles being added together, it's going to be the sine of the first, the cosine of the second, plus the cosine of the first, the sine of the second. And if I'm taking the sine of two angles that are being subtracted, it's going to be the sine of the first, cosine of the second, subtract the cosine of the first, the sine of the second. All right, if I am dealing with cosine, if I am doing the cosine of two angles that are being added together, it's always the cosine of the first times the cosine of the second, subtract the sine of the first, the sine of the second. And if I am subtracting those two angles, the cosine of two angles that are being subtracted, we have the cosine of the first, cosine of the second, plus the sine of the first times the sine of the second. All right, last but not least, we're going to focus on tangent. Tangent has the messiest formula, I guess. The tangent of two angles that are being added together, you actually have to deal with a fraction. It's going to be the tangent of the first plus the tangent of the second over 1 subtract the tangent of the first times the tangent of the second. And if I have the tangent of two angles that are being subtracted, my formula is the tangent of the first, subtract the tangent of the second, all over 1 plus the tangent of the first, tangent of the second. If you look at your trig sheet, these 6 formulas are on that trig sheet. You do not need to memorize these formulas. I want you to be able to use them. And actually, because of the shortened condensed 14.6, we are going to focus on the sine and the cosine portion. But I want you to realize that tangent is also an option. If you follow the formula, tangent is also an option as well. All right, anybody have any issues so far? Okay, so I'm going to deviate from what is on the note sheet just because we are going to be condensing this a little bit. Any issues or questions so far? All right, so we are using these formulas, and the first thing that I want us to look at, the first situation that I want you to look at, is finding the cosine of negative pi over 12. Going to be looking to find the cosine of negative pi over 12. Now, what do you think when you look at that? I can take away the negative? Why can't I just take it away? Okay, you're exactly right. Yes, the cosine of the negative angle is the same as the cosine of the positive angle. Absolutely, that is exactly right. Okay, I like that a lot. What else do you think when you look at this? 1 minus the pi over 12? Why 1 minus it?
Because it's already negative. So we need to take the sine of the formula.
Okay, yep, that would be exactly right. I got to tell you though, I think something way more basic than you guys, on the level you guys are thinking on at this point. And really good thoughts. But I look at this and I'm not really happy with it. Is there anything you're not happy with? Do we know where pi over 12 is? Yeah, I don't. So the first thing I would do is I would feel more comfortable with this if it were in degrees, okay? And I would not tell you to do that very often, but this is not an angle that we are used to recognizing. Pi over 3 we know is 60. Pi over 6 we know is 30. Pi over 4 we know is 45. There are some that we should be getting very good at. Pi over 2 is 90. 3 pi over 2, 270. Those are ones that we're beginning to recognize. But pi over 12 is not one that I recognize. What is pi over 12? 15, absolutely. 180 divided by 12 is 15. So this is really the cosine of negative 15 degrees. Okay? And I absolutely agree with Matt that the cosine of negative 15 is going to be the same as the cosine of positive 15. Okay? Let's progress like we didn't notice that. Okay? Now, negative 15, is he a nice one? Does he come from one of our beautiful triangles? No, he's not in a 30, 60, 90. He's not in a 45, 45, 90. However, using those numbers from our 30, 60, 90 and our 45, 45, 90, how would I get negative 15? 30 subtract, what did you say? 45 minus 60, absolutely. So the cosine of negative 15 is really the cosine of 45 subtract 60. All right, so now I look up here, I have the cosine of two angles that are being subtracted. All right, now the cosine of two angles that are being subtracted is the cosine of the first, so that's the cosine of 45, times the cosine of the second, which is the cosine of 60, plus the sine of the first, which is the sine of 45, times the sine of the second, which is the sine of 60. Is everybody okay with following that formula? Ladies, gentlemen? Yes, no, maybe? Yes, ma'am. The result should be exactly the same. Your math throughout is going to look different if I pick 30 minus 45, but the result will be exactly the same. Yep. Okay, so knowing that I'm looking with 45s and 60s, I'm going to have to draw two special triangles. I'm going to draw my 45, 45, 90, x, x, x root 2, and my 30, 60, 90, x, x root 3, and 2x. All right, what is the cosine of 45? These are ones that we probably should have memorized now once we look at our triangle. What is the cosine of 45? Yes, root of 2 over 2. X over x root 2 is going to simplify to root of 2 over 2. Times, what about the cosine of 60, Megan? Cosine of 60. X over 2x, and what is that going to simplify to? 1/2. Beautiful. Plus, all right, sine of 45. What is the sine of 45 going to be? Katie? Root 2 over 2. Times, what about the sine of 60, Zach? Which simplifies to? Beautiful. Okay, so now we're going to clean it up. Root of 2 times 1 is going to be root of 2 over 2 times 2 is 4. Plus root of 2 times the root of 3 is? Root of 6. All over 4. And if I want, I can put them together. That's going to simply be the square root of 2 plus the square root of 6. All over 4. An exact answer. No decimals. Exact answers, no decimals. Simplified radicals. Any issues, questions? All right, let's try one more. Second one that I want to take a look at. Let's take a look at the sine of 195 degrees. The sine of 195 degrees. All right, now, this is a situation where you might want your trig sheet out. might want your trig sheet out. And the reason that I might want my trig sheet out is because with these angles, I got to think a little bit outside the box. All right. As I'm trying to get 195, if I look at my unit circle, these are the nice angles on my unit circle. How in the world am I going to get 195? Obviously, 195 is not on here. It's not nice. So how am I going to get 195? 135 plus 60. We got 135 and we have 60. I like that a lot. Okay, so we're going to start out by saying, well, that's the sine of 135 plus 60. All right, the sine of two angles that are being added together. Sine of the first, so sine of 135, cosine of the second, cosine of 60, plus cosine of the first, cosine of 135, sine of the second, sine of 60. So far, so good? All right, now my 60s, gotta love them. Okay, we're just gonna simply make our 30, 60, 90 right triangle. Cross from 30's x, cross from 60's x root 3, hypotenuse at 2x. All right, what is the cosine at 60? Connor, what's the cosine at 60? How do I find cosine? X over 2x, which simplifies to 1/2. Good. So the cosine of 60 is 1/2. What about the sine of 60, Tessa? What is the sine of 60 degrees? Beautiful. X root 3 over 2x simplifies to root of 3 over 2. Okay. The challenging part comes when I start looking for 135. The challenging part comes from looking for the 135. Does anybody have an idea on what we're going to do to find the sine and the cosine of that 135?
You draw it on the graph and then you find the reference.
Beautiful. We got to be working with those reference angles. So when I start drawing my picture here, where does 135 degrees take me, Samantha B? Where does 135 degrees take me? What quadrant am I going to be in? Yep, second quadrant. I'm going to go 135 degrees. All right, and I'm going to draw that triangle. I'm going to draw that triangle to find that reference angle of theta. How much is theta going to be there? 45, absolutely. So I know that I'm going to have a 45, 45, 90 triangle. Across from each 45 is x. My hypotenuse is 2x. All right, now, is that okay? What else do I need to add to this picture? Zach? Which one's going to be negative? You bet. I went to the left x, so that means that this one's going to be negative. Ach. X square root 2. Sorry about that, I just wrote it wrong. Maybe I said it wrong too, I'm not sure. All right, now, what is the sine then at 135? Alex V, what's the sine of 135? All right, I'm going to have opposite over hypotenuse, so that's x over x root 2, and that's going to simplify to root of 2 over 2. I like that very much. Plus, what about the cosine of 135? What about the cosine of 135? Levi? Negative root of 2 over 2. Adjacent over hypotenuse is going to be negative x over x root 2, which is going to simplify to negative root of 2 all over 2. All right, we're cleaning it up here. Root of 2 times 1 is going to be root of 2 over 2 times 2 is 4. Subtract root of 2 times root of 3 is going to be root of 6 all over 4. So if I clean that up, it's going to be the square root of 2. Subtract the square root of 6 all over 4. Exact answers, no decimals. Simplified radicals. Now, can I use my calculator to check?
Yes.
Certainly. And I would certainly encourage you to do that. Take the root of 2, subtract the root of 6, divide it by 4, and then hit sine of 195 and pray that your decimals match. Absolutely would encourage you to do that. Any questions? Any questions? All right.